Good afternoon. Today we are completing Geometry Lesson 5.5, which is providing reasoning for steps of a geometric proof, completing only the left-hand column of the proof. So if you'll remember, we first in Lesson 5.1 talked about conditional statements with hypotheses and a conclusion, and how some of them were inductive, meaning they were based on proving on proof that was from the observation of whoever it was utilizing the proof, and would continue to use until they found a counterexample. And then also deductive reasoning, which was based upon some proof that was found by somebody in the past and recorded and used again and again and again. So we did that in the first lesson. The second lesson, we looked at algebraic proofs, and so that was a bridge from algebra to geometry. You've done many algebraic proofs, and so you've seen how the logic flows with algebra. Now you're applying it to geometry. Then lesson 5.3, we did one-step proofs, which were basically two-column proofs where you were given some information and told to prove it, and the proof was the reasoning step, and so that was your actual one-step proof. We did both algebraic and geometric one-step proofs. In 5.4, which I just gave you, we did a geometric proof. It was a two-column proof, but the statements on the left side were filled out, the reasons were not on the right. Now we're reversing that here in lesson 5.5. This is another geometric proof we're going to do, but this time we're completing the left column of the proof because the right column, which contains all the reasons, is already there. And so that's a little bit trickier, but it still can be done. So you're going to recognize and write the reasons for the steps of a geometric proof. Steps, I should say, for the reasons for the steps of a geometric proof. And also the steps. So let's change this. Recognize and write the steps. So we'll take out the reasons and write the steps of a geometric proof based on reasons provided. So I amended that slightly, okay? And you also have a lesson on geometric proofs provided in the lesson links calendar. I've written it out there so you will see it. It is not going to be a worksheet. It will be an IXL lesson. Okay? So you'll see that in the calendar. Okay, you're going to, of course, take notes on this. You're going to make sure you fill out the header, like I've always said, and you're going to upload that to my Student View Dropbox. And in this case, I'm going to give you until Wednesday to do that. So you get a little extra time to complete these, and your test is going to be, depending upon which period you are, either Thursday or Friday of next week. Monday and Tuesday we will be doing the review. Mondays for periods 3 and 5, and Tuesday will be for period 6. Okay, so let's take a look at our example, which is using a two-column proof to prove that lines are parallel. And so we're going to we have used in the corresponding angles converse in the previous lesson. We're going to use it again here, but we are also using the corresponding angles postulate. So this is the postulate, this is the converse. You'll see they're very similar. And so the postulate says if two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. Okay? And the converse is that if you have two lines that are cut by transversal, so that corresponding lines are congruent, then the lines are parallel. Okay, so it's just switching the hypotheses in the conclusion. And in this case, both are true. All right, so now we look at our example. So you're always given a drawing, and look to the drawing first to see what's going on. So you have 3 lines here, M, N, and K. And then you have an unidentified transversal that goes through all of them. You'll notice that angles 1, 2, and 3 are also identified here. And then over here is the given. So they tell you that M is parallel to N. So M and N are parallel. Okay? And so I'm going to show that by putting a single arrow kind of in the back of each of these two. Then they tell you, though, that N and K are also parallel. Well, here's N, and I'm going to put a double arrow. It's parallel to K. So I'm going to put a double arrow there. So they want you to prove that M and K are also parallel to each other. Now that seems like it might be obvious, but you have to come through and do it. So they give you that M is parallel to N and line N is parallel to K. That's the given. Now they tell you the reason for the next step is the corresponding angles postulate. So you're going to say, well, okay, let's go back and look at the corresponding angles postulate. So here it is. If 2 lines are cut by a transversal, then the pairs of corresponding angles are congruent. All right, so we're talking about lines M and N. They're cut by a transversal. So that means then that these corresponding angles 1 and 2 are congruent. All right. So how would you restate that? You would restate that as angle 1 is congruent to angle 2. I mean, that's all. That's as simple as it is. Angle 1 is congruent to angle 2. All right. So you looked at the corresponding angles. These were it. And they obviously have to be the congruent angles that are being talked about in the postulate. All right, then they've got another given. Well, so the first part of this given was actually for MN. So I'm going to take this one out here. Really should have been just for this part. So angle M is parallel to angle N. That's given. And so here's M and N. Here were the corresponding angles. And we said that corresponding angles are congruent if the lines are parallel. So the angles are angles 1 and 2. We put that in. Now the second given has to be the second part. It's the N is parallel. So N is parallel to K. All right? That's the given. Now that's the corresponding angles postulate is the reason for that. So that's angles 2 and 3 we're talking about. Let's look at the corresponding angles postulate. Where to go? Here it is. So corresponding angles postulate, if 2 lines are cut by transversal so that the corresponding angles are congruent, then the lines are parallel. Okay, so so we've got these 2 angles, and they said that if you've got 2 lines that are cut by transversal so that those are congruent, then the lines are parallel. All right, so that's lines 2 and 3. So, or I'm sorry, not lines, angles 2 and 3. So angles 2 is congruent to angle 3. Right? All right, now the next reason they tell you before you get to the fact that these are parallel is transitive property. Now what are they talking about, transitive property? So you've got to go back to algebra. And basically algebra says, and this is transitive property, so if A equals B and B equals C, then A equals C. So if M equals N and N equals K, then M equals K. So that's transitive property. Okay? So basically, if angle 1 equals angle 2, and angle 2 equals angle 3, and we've said angle 1 and 2 are congruent, angle 3 has to be congruent to angle 2 as well. So then angle 1 is congruent to angle 3. So that's the conclusion. Angle 1 is congruent to angle 3. All right? So that's it. That's the steps. And we are done with this. This was the shortest video I think we've ever done. Almost just under 11 minutes. So that's it for this one. We have one more video to go. I expect to have that by the morning. That will cover doing a proof where we're filling in both the statements and the reasons based just upon the picture and the given in the proof. Okay? All right. Talk to you later.